So actually start with this example with a map. Maps are two-dimensional, but they represent a graph of the Earth. And so in math, we use what's called a coordinate plane. Cartesian, it's based off a mathematician, but the coordinate plane is 4 quadrants, which hopefully this part's review. It goes counterclockwise, quadrant 1, quadrant 2, quadrant 3, quadrant 4. You have x, y are positive here. X is negative, y is positive here. They're both negative here. X is positive, y is negative here. And those are your 4 quadrants of your coordinate plane. And so we're going to very quickly talk about graphing. Hopefully we all know how to graph and label each point. When you're graphing it, the first number tells you your x, which is your left and right movement. The second number tells you your y, which is your up and down movement. So 2, 4, you would go right to up 4. You would put your point there. And when you're graphing these, you actually need to label them. So you would need to put the A there as well. The next one is a positive negative. So again, you're just going to move 3 in the positive, 2 in the negative, and then you're going to label that one. And so hopefully we have all graphed on the coordinate plane. And then you should be able to recognize graphs on a coordinate plane. Now, this is where we started getting into a little bit of terminology here. Any set of ordered pairs is called a relation, all right? And so they can represent it multiple ways. They can just give you a list of them, x's and y's. They could give you a coordinate plane with a graph of them, or you can have what's called a mapping diagram. A mapping diagram, it has 2 figures, sometimes rectangular, sometimes circles. One represents domain, one represents range. And then you list your x values, which is your domain. And you'll see you have 1, 3, and 5. You'll notice they did not list them twice. Even though the 3 was listed twice, they only put it there once. And then they listed their y's. You'll also notice they did not list them in the same order. They listed them least to greatest, okay? Domain, that is your input. So that is your input values. That's typically represented by x. Range, those are your y values represented by your y and your output. And then what they did is they drew a line. So 1 went to 3. So you'll see the line from 1 to 3. 3 went to -1, from 3 to -1. 3 also went to 2, from that 3 to 2, and 5 went to 4. That is a mapping diagram, okay? Label your domain and range, least to greatest, do not repeat it, and draw your arrows. All right, so there's 3 ways to represent it. So they want us to use this set right here, this relation, and represent it with a set of ordered pairs, a table, a graph, and then state the domain and the range, all right? So if I did it as a set of ordered pairs, I would say, well, it includes the ordered pair -1, which goes to -3, and I can follow that along. It also includes 1, 1, and it includes 3, 5. That would be my set of ordered pairs. If I wanted to do a table, I would simply do an XY table, and I would list my X's and the Y's that correspond to it. If I wanted to do a graph, I would do a coordinate plane. And I would put those points on there. So I would say -1, -3. +1, 1, +3, +5. All right. Now, if they want me to list the domain, they typically want that in set notation. So you would say domain, you can just say a D, that's fine. And again, you would list it least to greatest and you wouldn't repeat anything. Range, set notation, least to greatest, and you wouldn't repeat anything even if it did. All right. So those are multiple ways to really tell the same thing. All of those represent this same relation, okay? Now, they can give it to you this way. Example 3 at the bottom of page 57. And they can say, state the domain and range. And here they've given me this, this, and this. This is easy. Domain, you're just going to list your X's and your range, you're going to list your Y's. Very simple. Here, Here you have to pay attention to what's happening. So when they give you a set of points and they want domain and range, you literally domain, list your X's, range, list your Y's. Simple. When they give you a graph like this, you need to pay attention to where you start and where you finish, okay? So my X values start here and they go to here, all right? So my X values include, and it's a continuous line, so it's going to include starting in -1, and it's going to go to +2. All right, from -1 to +2. Now, here's the thing on this one. Down here, we have an open circle. On a number line, what does an open circle represent? What does it tell you?
One is greater, one is less than.
Right, so it's either greater or less than. It does not equal that point, okay? So if you're telling me that this way, you actually use a parentheses versus a bracket. So if I wanted to tell what the domain is, I'm actually not going to list points because I would have to say -1, -0.9, -0.8, and every number in between because it's a continuous line, which is hard to do since there's irrational numbers in there, right? So you actually just give me a set showing me that it includes it. So it doesn't include -1, that's an open circle. It does include +2, that's a closed circle. And so you represent that with these open brackets and closed brackets. You can also do it in set notation. So this is called interval notation. Set notation would tell me X is such that -1 is less than X, which is less than or equal to 2. And those mean the same thing. All right? Look at range then. Range is my Y value. That starts down here at -3 and it goes up to +3, but it doesn't actually include it. So once again, you would say -3 is not included, +3 is included. Or in set notation, you would say Y such that -3 is less than Y, which is less than or equal to +3. All right? Interval notation and set notation. There's two ways to do it. Your book only shows set notation. I teach both. All right? Because sometimes it's easier to do the interval notation. Look at the next one. So the next one, my X value starts at 0. Where does it end? If it starts at 0, where does it end? Does it have an end, I guess, should I ask? Arrows. The arrows indicate what? That it keeps going how far? Infinitely. And that's actually what you would put. Now, for infinity, you never do inclusive because it's not an actual number. All right, so you can actually include it. In the book, they actually would probably write it like this. X such that X is greater than or equal to 0. All right? Y. What's my smallest Y? My range.
0.
Let's wait. I mean, we have an arrow that keeps going this direction. What's my smallest Y?
You don't have a smallest Y.
Right. So how do we represent that mathematically?
Infinite.
Specifically, we would say negative infinity, right?
Oh, okay.
All the way to positive infinity, right?
All real numbers.
Yes. X is an element of all real numbers.
Why would you say
Yep. Yep, all real numbers. Function. So a relation is any set of ordered pairs. It doesn't matter. Any two things paired up, that's a relation, all right? A function is more specific. It is a type of relation, so you're going to have sets of numbers, but every element of the domain is paired with one and only one element of the range. So it's a one-to-one relationship from the domain to the range, okay? Meaning for every X, you're going to have only one Y. It doesn't work the other way. You could have two X's that go to the same Y, but you can't have one X that goes to two different Ys. I do this when I think about if you've ever gone to Walmart and had to self-checkout, right? If you have two packages of the same cookie, right? And you ring it up and it's $2.50. If you ring up that barcode again, it should be $2.50, right? If you ring it up again and it's $3, something's wrong, right? Especially if it's the same package. So every barcode has one and only one price attached to it. That does not mean that you couldn't purchase bread and that also be $2.50, right? Doesn't mean that two things can't cost the same, but the same two items should never cost different things. All right, that is a function versus a relation, okay? A relation says it doesn't matter how you pair them up. A function says every x can only have one y. And if it has more than one y, it is not a function, all right? So they've given us some examples here. This first one, again, this is a mapping diagram. They've listed our domain, they've listed our range. You do not list it twice, and this is why, because this will give you a clear picture as to whether or not this is a function. -1 only goes to -3. +1 only goes to +1. 3 only goes to 5. This is a function, all right? Look at this one. 1 goes to 3. 3, however, goes to -1 and +2. This is not a function. This is a relation. It's not a function. We have a problem here. This one, -2 goes to 4, 0 goes to 4, 2 goes to 4, and 4 goes to 4. This is a function. It doesn't matter that they go to the same thing. It matters that each one of these only goes to one number. All right? So the top and the bottom are functions. This middle guy is not a function. Not a function. The mapping diagram is really easy to see. So if we go here first, is this a function, yes or no? And if, why or why not?
No.
No, and why not?
Because it's 8, 7, and 8, 9.
Right. So this guy has 2. We have a problem, all right? These, you can pretty much tell with your ordered pairs because your x value will be repeated if it's not a function. We have 1, 2, 2, 1, and 3, 2. This is a function. If it were not, you would see another group with like 1, 3, right? You would see your x repeated, all right? It doesn't matter if your y is repeated, but if you see your x repeated with ordered pairs, you have a problem. With graphs, you can tell by just drawing a vertical line. It's called the vertical line test, all right? The reason this works is your vertical line represents your y's, right? So up and down represents y. And if I were to draw a vertical line on this graph, if it is a function, I should only cross it one time because this y value should only have one x, right? So that means this x equals 1, should only have one answer. But on this guy, x equals 1 has 2 answers. Do you see that? X equals 1 has this answer up here and this answer down here. This is not a function, and it's called the vertical line test. You literally draw a vertical line anywhere on the graph, and you should be able to only cross it one time. If at any point on the graph you cross it more than once, it is not a function. So no more than one time. This next one would be a function because I can literally draw a line anywhere on this, and I am going to cross it only one time. Those are steep slopes, but they're still slopes. So you're only going to cross it once. So a couple things here. I pulled these paragraphs out because I wanted to point out a few things. Functions can be described as a rule for how you get x, the input of x, how it gives you a y. For example, y equals 2x minus 1 is a rule. So if I need to find y, I would multiply x by 2 and I would subtract 1. That is the rule for that function. Function notation is what you're going to use really as you go forward in math. And so the function notation, instead of writing y, they'll often write f of x. It's a little f with parentheses x. This is how you read it, f of x. It is telling you that x is a function. It's a function of y based on x. It is telling you what your input value is. Your input value is x. And the way you get your output is multiplying that value by 2 and subtracting 1, or whatever the rule tells you to do, all right? F of x equals 2x minus 1, or the function of x. So y is a function of x. You have terms here in this next section at the top of page 59. The variable representing the domain is typically x. It is called the independent variable. The range is the y or f of x, and it is called dependent because it depends on what x is. So to find y, you put x in to your rule, and y depends on what x is. That's why it's called dependent, the dependent variable, okay? So if they want you to find a specific one, find f of 2, all they mean is plug 2 into your rule and get an answer. All right? So if you look at example 5, they want us to evaluate f of x equals 3x minus 5 for the domain -2, 0, and 4. So evaluate always means solve, right? You're just solving. So you would plug this in and you would basically just do order of operations at this point because you're going to have all numbers, all right? And so they want us to find f of -2. That means I am going to use this rule to find that. I'm going to say 3, and instead of x, I will write -2 minus 5. That is -6 minus 5, which is -11. So f of -2 is -11. What does this tell me? This actually tells me an ordered pair. This actually tells me that I have this ordered pair in this relation or function, all right? F of 0, again, that just means plug it in. That's going to equal -5. That also tells me this ordered pair. And then f of 4. We have 3 times 4 minus 5. That gives me 7. So then that tells me this ordered pair right here. All right? And so they have given me a rule. They want me to evaluate it on these 3. And so a lot of times people will try to then divide. They think this is some type of multiplication. It is not. It is just telling you what to plug in. What to plug in to your rule. You will then get a numeric answer, right? You'll get a numeric answer because you will have plugged it in for every x that is in your rule. All right, so I want you to try one of these. All right, so to get these, you're going to plug it in. So the first one they wanted was g of -9. You're going to say 4 times -9 minus 2. 4 times -9 is -36 minus 2, which is -38. So that's where they would have gotten this one. The next one, g of 2. You're going to plug in a 2 there. 4 times 2 minus 2, you get 8 minus 2, which gives you 6. That's where we got this one. And then the last one, g of 6, you would say 4 times 6 minus 2, which is 24 minus 2, 22, which is where they got this one. So you're just plugging it in and then do order of operations. All right.